Yeah, good morning everyone. Today's video will be looking at the case of redox reaction. Now, as the name implies, redox, it simply means reaction that occur where there is oxidation and reduction occurring simultaneously. That's what we describe as a redox reaction. We'll first look at the case of oxidation, reduction, or redox, or reduction and oxidation before we now look at redox reaction proper, maybe in the next video. But starting with the case of oxidation, first going by the definition, oxidation has several definitions. Starting with one, it involves loss of electron. It involves loss of electron. It also involves addition of oxygen. Addition of oxygen. Addition of oxygen. It also involves removal of hydrogen. It also involves addition of electronegativity. When you add electronegativity elements, it's also defined oxidation, and also involve addition of, or may I say removal of electropositivity elements. When you remove a positive element, you also define oxidation. And lastly, you can see it involves increase in oxidation number. It occurs when there's an increase in oxidation number. This defines oxidation. Then when you reverse this definition, you'll be achieving the case of reduction. That is, in reduction process, there is a gain of electron. In reduction process, there is what? Removal of oxygen. In reduction process, that is, there is addition of what? Hydrogen. In reduction process, there is what? Removal of what? That is addition of electronegativity, and there's removal of what? There's addition of electropositivity and removal of electronegativity. Sorry for that. Then the last one is now there's a decrease in oxidation number. This is what tends to occur in the case of oxidation and reduction. Now, whenever this process occurs, there is always an element or compound that bring about the process. We describe them as reducing agent and oxidizing agent, or we can also say that reducing agent is an element or compound that lost electron. In terms of oxidation, that lost electron, that's for reducing agent, it lost electron. It's also what a reaction element or compound which tend to what involve increased oxidation number. In the case of reduction, we can also refer to what? Oxidizing agent. Now, whenever oxidation process occur, the agent responsible for this is known as reducing agent. In reduction process, the agent responsible for it is known as what? Oxidizing agent. Now, if you are to go by the example that I have here, look at this now. We have this example here. When carbon as an element combined with zinc oxide to give rise to carbon 4 oxide plus zinc, if you observe this following my arrow here, it is shown that what? There was addition of oxygen, carbon added oxygen from zinc oxide to achieve carbon 4 oxide. And whenever there's addition of oxygen, like I said earlier, the process is called oxidation. And like I said earlier also, when oxidation process occur, the agent responsible for it is known as what? Reducing agent. We'll call it reducing agent, or can also call it reductant. Now, for the case of this now, when this process occur now, this carbon accepted oxygen to form carbon 4 oxide and zinc oxide was formed. Oxidation process occur. The agent is known as reducing agent. And what will happen to this agent after the reaction? After the reaction, this agent end up becoming what? Oxidized. It end up becoming oxidized. Oxidized, what does that mean? It will gain electron, or it will increase. Now, gaining meaning that what? Here, its oxidation number here is 0, while here it is now what? It is now 4. Going by the calculation, because it's uncombined, the oxidation number is 0, while here it is what? It's 4. Now, come down to the case of if I have my arrow going like this now, what occurred there? You see that what? Zinc oxide loses oxygen to form ordinary zinc. And as this occurred, there was removal of oxygen. whenever there's removal of oxygen, what can we call that type of reaction? We call that type of reaction reduction reaction. And when reduction reaction occur, what agent is responsible for reduction reaction? It's always known as what? Oxidizing agent. Now, who is oxidizing agent here? Now, in the case of this, as you see, oxygen was removed to give rise to what? Zinc. Here, that process is described as reduction, and the agent responsible is known as what? Oxidizing agent. And who is oxidizing agent here now? Is zinc oxide. Is oxidizing agent. The agent is always the element or compound that bring about the process. You understand? That's what we describe as what? As the agent. So here, zinc oxide losses also into ordinary zinc. If you look at it here, at the end of the day, this zinc oxide end up becoming what? Reduced. End up becoming reduced. Reduces mean that was to reduce oxidation number. That is, here it was zinc 2 oxide. That is oxidation state of +2 here, while here it is uncombined to become what? 0. Now looking at the other example here, this is iron 2 chloride combined with what? Chlorine to give rise to iron 3 chloride. Now for us to get this now, there was addition of what? Chlorine to give rise to iron 3 chloride. Here chlorine was added, and when there's addition of electronegativity, we describe that type of reaction to be known as what? Oxidation. And whenever this oxidation process occurs here, we call the agent responsible as what? As reducing agent. You understand? Now, being a reducing agent, you know it end up becoming oxidized. Now, here it was green. Here, added chlorine to give rise to what? A brown color of iron 3 chloride. This is known as what? Oxidation process. Now, if you look at it in this manner, let's say for instance now, this same iron 3 chloride tend to what? Remove chlorine. If it remove chlorine, what will happen here now? It will give rise to what? It will give rise to, if you remove chlorine from this place, to give rise to this. But let's say if you follow the arrow like this now, iron 3 chloride losses or remove chlorine, it will give rise to what? Iron 2. If it's remove chlorine, that had been another type of reaction. That is, there was removal of chlorine as electronegativity. And when that occur, that process is described as what? As reduction. And when reduction process occur, the agent responsible is always known as oxidizing agent. And who is oxidizing agent here now? This compound, iron 3 chloride, is the oxidizing agent. What happened to it? Like this place, reducing agent become oxidized. Here, oxidized agent end up becoming what? Reduced. How? How is it reduced? It was reduced from iron 3 chloride to iron 2 chloride. That is, chlorine here, sorry, oxidation state of iron here was 3, then here it now happens to become what? 2. Here it was oxidized. That is, this will be oxidized. Oxidized means that what? It increased from what? From iron 2 to iron 3. Reduce meaning that it reduces from what? From iron 3 to what? Iron 2. Here it was reduced. Come to this now. H2X, a common gas that have the smell of a rotten egg, when combined with chlorine, ended up giving rise to HCl plus sulfur. Now in this case here now, there was, you see, H2X give rise to this. What does that mean? Chlorine was added, H2X combined with chlorine to remove sulfur, at the same time add chlorine. And when chlorine was added, that process is described as what? As oxidation process. And when this occurs, the agent is known as what? Reducing agent. Who is the reducing agent? Hydrogen sulfide. This is the reducing agent, also known as reductant, because it's the one that brings about the process of what? Oxidation. Now if you watch this now in the reverse manner now, here we have this. When there's also removal of hydrogen to give rise to chlorine, we call this process what? When there's a removal of hydrogen to form chlorine, we call this also oxidation. Now let's say for instance here now, chlorine here tend to what? Add. Let's say chlorine, if I reverse this arrow now, let's say chlorine here end up adding with hydrogen to give rise to what? HCl. Since chlorine accepted or removed hydrogen from this side to form HCl, there was addition of hydrogen. And whenever there's addition of hydrogen, we call that type of reaction reduction reaction. And when reduction reaction occur, the agent responsible is known as what? Oxidizing agent. Who is oxidizing agent here now? Chlorine is the oxidizing agent, otherwise known as oxidant. Oxidant. Now, what will happen to chlorine after this reaction? Chlorine end up becoming reduced. It end up becoming reduced. How? Here is an oxidizing agent, end up becoming reduced. Here, chlorine oxidation state here was 0. but here it is now negative. How? For instance, to have it as HCl, calculating oxidation number, here is what? 1 plus chlorine equals to 0, then my chlorine equals to what? Minus 1. That gives rise to minus here. So here it is minus 1, here it's 0. Of course, 0 is greater than what? It's minus 1, meaning that it was reduced to minus 1. This gives rise to common example to this. Now, in summary of this, it simply means that whenever there is oxidation process, the agent responsible is known as reducing agent, or we can also call it reductant. And the agent end up becoming what? Oxidized. And when there is what? Reduction process, the agent responsible is known as oxidizing agent. And this agent will end up is also known as oxidant, and end up becoming what? Reduced. This is summary of this process. Maybe in our next video we will now look at how both oxidation and reduction can occur in a reaction simultaneously, and how to balance what? Redox reaction properly. Thank you.